Okay, I think I'm gonna spend the next 2 hours studying Uniswap. Maybe less than that, but because it's already late here. One thing that I realized is that I'm studying Ethereum, but you would probably be good to study other ecosystems as well to understand how similar and different they are from Ethereum. I know that Solana works on accounts, but yeah, I'm not sure exactly how Cardano works. I think it works by proof of stake, but I didn't spend a lot of time trying to understand those ecosystems and how different they are, what kind of computation they can do. Because in Ethereum, I know that you can create smart contracts, but on the other ones, I'm not really sure how it works and exactly what you can do and you can't do. So probably at some point I'll take a look superficially, not go into too much depth, but I'll take a look at the major ones, which I think is Cardano, Solana, and then maybe Polkadot and Avalanche. I'm gonna put some music. I think I'm gonna put this on the other screen and I'm not gonna look at the comments. If anyone comments, just so I can have more space to look at the stuff that I wrote and go over the project. I think this is yarn. Let me do something. Because I realized that there is a risk that Ethereum becomes completely controlled by the government and starts to crash, and then it's better to have an idea of how the other ones work instead of being too invested into the Ethereum ecosystem. I want to take a look at the contracts actually. I think I'm gonna close this stuff here, which is stuff that I changed just so that it runs and it doesn't crash. Yeah, the interface. So they're using Web3 React, which is the same one that I used to create my NFT marketplace. The way that it works is it creates a context under the hood to make that person stay connected in the website. We actually don't have any control whether or not the person. You can't disconnect someone from the site. They have to manually do it, but I think it stops listening to the events once you log out the user. Oh, the other thing that I just read off stream is that with the with the merge, after the merge, they're gonna do something called sharding, which is when you scale a database horizontally. And the reason why they're gonna do that is because if you scale vertically, which is, I believe, the SQL format is usually scale vertically with SQL, and no SQL is scale horizontally. And the reason why you do that is to increase the capacity of the database. And the reason why they're gonna do that to scale horizontally is because that's gonna allow more people to run nodes, because the hardware requirements are gonna decrease. So it got me thinking about whether or not it's worth it to, but I think it's gonna end up being worth it to get the 2 terabytes SSD, and maybe in the future some GPU, because I think there are gonna be other uses for the amount of RAM that I don't use to run the node on Ethereum. But it's good to know that I'm gonna actually use less than I think the one I was preparing to use to run the node. But I think the sharding is only gonna happen in 2023, so there's still some time. So they're only listening for the block event, seems like. Let's see if I can get the nav bar here. It's probably here. And this is probably more interesting than looking at this. I don't understand why they don't have to put the two dots here to access the file, the folder. And they're using Redux, maybe, because of this. I guess these are all the reducers. Yeah. I guess this is the main thing there. Is this stuff here. Or maybe not, maybe it's this one. It's the same vote there. And it's probably this. So this part is the header there. Or maybe this one is actually. Oh, this is the interface for V2. Not sure really. Maybe because I don't understand where is this thing here. I guess I can just remove stuff and see. Oh, maybe it's this thing here. And this is the liquidity stuff. And it's probably this thing here. And then, yeah, this is the connection to the contracts. So this is the little block there, this stuff here. And then, depending on where you are, I guess, yeah, if you have, then it's a different thing. I guess I'm starting to understand now, I think. It's very complex because there's a bunch of different files connected with each other, but I think if I spend some time, it's not going to be that hard actually to understand how everything is connected. Because you can always start from the main thing and then go through the navigation and figure out how each path is connected to the other. Obviously coding this was probably really hard for them. But something else. I'm gonna move through the graphs to the other folders. I'm just trying to see if I can find the way that which smart contracts they are using here to do the swapping and the liquidity. Maybe probably I'm more curious about the liquidity than the swapping. I guess all of the logic is on the state folder. So I should probably just look at these ones. State user hooks. Yeah, they are using Redux. Oh, so it jumps to the... Oh, it's actually on the node modules, but it's the same one that I have on the main folder. Because I guess the interface, obviously the interface has to have the contracts. Using the core here. So this comes from the core contracts. I guess this is the declaration file. Interesting. So the router address is this one. Hmm. So maybe I feel like I should write this somewhere because there it has all the addresses here. And the factory comes from this one, from the SDK. But I guess I'm gonna look into the other folders. Hmm. Trying to look at everything fast because I want to move on to the other ones. Just wanna have a sense of how this stuff is organized on this one. I guess I'll move on. I'll leave this file open so I can look at later. I'll probably write these addresses down somewhere else, some file, in case I need it in the future. Oh, I was gonna try to see the liquidity contract, if I can find it. Yeah, it's probably these ones. It's probably the one that I was already looking at. Yeah, there's a lot to look at here. Same file on the other one. Yeah, whatever. I think I'm gonna open the other projects now. So it looks like the Uniswap V2 pair implements score swapping and liquidity provision functionality, which is this one. The factory deploys Uniswap V2 pair contract for any ERC20 token. Periphery is an initial set of helpers including router contracts, performs a safety check, checks needed for safety swapping, adding and removing liquidity. Migrator contract can remove liquidity from Uniswap V1 and deposit into Uniswap V2 in a single transaction. Library contract can be used in the creation of the other helper contracts. Yeah. Well, maybe I should look at the V3. I think it should be the same thing. But this one is spool and the other one is spare. But I think it's probably really similar. I guess this is the mutex to prevent re-entry attacks. Yeah, that's the point of this, I think. And I think this is fairly old because of the version of Solidity. But I didn't know that Uniswap V2 was that old. Or maybe things are evolving really fast, so... Because I think Solidity is probably on 0.8 version or something like that. 0.9. Oh, this saw there calculating time. I don't understand why overflow is desired there. You get the block timestamp, then divide by this huge number. Where's this coming from? No, from the... I think it's from... Okay, from here. So it's kind of like a global variable. So this never overflows and this overflows. Oh, I think I remember reading something about this one. Yeah, it's because of the size of the stack, I think, that this one is used. Maybe I wrote it down here. Probably. Yeah, this Uniswap v2 uses binary fixed point formats, format to encode and manipulate prices stored as this value here. Numbers, meaning that 112 fractional bits of precision are specified on either side of the decimal points, no sign. These numbers have a range of very large range, and the precision of 1 divided by 2 elevated to 112. This format fits uint 224, leaving 32 bits of a 256-bit storage slots free. The extra 32 bits on the end of the storage slots for the accumulated price of A divided by B and B divided by A are used to store overflow bits resulting from repeated summations of prices. I guess that's why the overflow is desired here, is storing bits from repeated summations of prices. But I don't understand really well why they did it like this. So this is a property of the thing. But what happens if it isn't? Yeah, so nothing really crazy here, actually. They're not using anything from the assembly thing. The only thing that is crazy is the U UQ 112 type and this explanation, which I don't understand really well. The extra 32 bits on the end of the storage lots for the accumulated price are used to store overflow bits resulting from repeated summations of prices. I don't understand why you want to store the repeated summation of prices. I guess it's because of because you wanna update in relationship to the previous blocks, but I don't get how this works really well. I guess the overflow only goes up until 32 bits in that case, and then yeah, but it doesn't make a lot of sense to me. It makes sense on the conceptual level, but to think about what's happening on the byte and bits level and the EVM, it doesn't make sense to me. So maybe I think I'll probably study that after maybe 2 days from now, because I want to clarify this. But I think what's happening is they want to overflow because they want to have the continuum, because this is the update from the previous block, and they want to make the reserves the update as close as possible to the other one. So it's like a continuum, something like that, and that's why you have the overflow. But maybe it's totally wrong. Yes, this is division probably. So it's dividing the price cumulative last is equal to the reserve 1 divided by the reserve 0 and times the time elapsed. And the price 1 is the other way around. So it's getting the price and then summing to the cumulative price. Oh, I guess I understand, because the cumulative price is the history of the prices. So it's overflowing to optimize, maybe. That's what's happening. I think I kinda get it, but it's worth looking more into it, I think. The rest doesn't look that interesting. Let's look at this one. I guess it's worth looking at the factory as well, because the factory is supposed to deploy this one, I think. No, this one has the assembly stuff. this function probably comes from these ones. And you swap with your pair. But maybe not. Yeah, no results. So maybe, but it seems like it doesn't make sense for it to be from Ethereum. I don't think this comes from low level Ethereum. The OP codes. But maybe it does actually. But yeah, I don't know, not sure. I know that add and mload are from OP codes, but this one, no idea. I guess it has to be, unless it's from the interface. That's not here. No, so it is from EVM. It's a little bit strange, the name. So I thought it wasn't gonna be. Interesting. So I guess this contract just does the fees and then creates the pairs as well. Because it is inheriting these things here. So this is the one that it stores the pairs, I think. It looks like on this mapping here. Oh, address. It pushes the pairs to the addresses, but it stores on the get pair here. Yeah, let me look at the V3 stuff. And V3 is still version 0.7. And it seems like it was really recent. But I'm not really sure actually. Maybe it has been some time that they deployed this. Or it's actually probably, I'm not sure if it's more than 2 years, probably not. More than 1 year. they're probably doing this for preventing people to store stuff on the memory. Because I remember from reading the articles that delegate call is used to, from reading the roll-up stuff, is used to put stuff on the memory. And it's probably because of some hack. And this I don't understand. I think it comes from. I remember reading stuff about contract abstraction, but a long time ago, and I think it has to do with zero knowledge proofs as well. But I don't remember really well. So I guess it's the same pattern from Python and everywhere else of abstract classes. So it's pretty much an abstract class, and it's usually used for having a template of things you want to do. So you put the functions that you want to be inserted with that template, and then you inherit the abstract class on other contracts to implement those functions. So you have, it's more of a software design thing, I think. Yeah, I get it. This one is also interesting to look at. Interesting, they are implementing binary search here. Yeah, I don't understand how they get it though. Like where are the observations coming from? Because it can't be from their own contracts. This is the stuff that I was thinking about. To understand how the liquidity works. If people can put money there and then withdraw whenever they want, or how does that work? That's the question that I was confused about. Hopefully I can understand. think the interfaces just have the functions, so it's not really interesting. The function declarations. But these ones might be... There are probably a lot of stuff here. Yeah, so it is re-entry protection using mutex. Only owner modifier. And I guess this is the factory, which is the same as this one. So it's the same patterns, but with different names. And then obviously different logic to handle the price variations and the liquidity. And then have max liquidity per tick spacing to max liquidity per tick. So this comes from the libraries. Probably the virtual reserves stuff is somewhere in the libraries here. I would guess. And liquidity map is probably here. Maybe not. Or maybe it's just that this stuff here. And the tick is probably the most interesting, because there's more files here. So maybe they zone the tick, the virtual reserve logic. Oh, so that's what they were doing on the other one. by getting the modulus, divided by the modulus, getting the modulus of true elevated to 32. I think it was this one. No, it was on here. Where did I saw that? Well, it has to be on the, or maybe not. Maybe it is here actually. Using that UQ112 variable. Yeah, this one. So this is what they're doing here. And go back. Oh, here. Returns the block timestamp truncated to 32 bits. So this, oh yeah, it's because of modulus division. When you get the modulus of 10, you reduce the precision of the number. So that's what they're doing by dividing by this number here, which is 32 bits. I think I get it now. And that's why they are doing the block timestamp like this here. It's just lower accuracy on the value, because probably it's a very big value, big number, and they don't want overflows on the multiplication. Same thing as the previous one, obviously. I don't understand why different functions though. Why not just make one function to get the balance? But yeah, makes sense, because maybe you just want the balance of either one of them. But you could have the same, yeah, you could have one function and then just pass a different argument. So yeah, I don't understand why they didn't do that actually, instead of having two different functions. There's probably a reason though. So I guess that's where the observation, the oracle there is for the ticks. But I'm not understanding this really well. I'm thinking about why did they decided to do the mutex instead of the no reentrance or no reentrancy from Open Zeppelin. And if I had to guess, it's probably because they have to they wanted to decrease the dependencies on other external contracts. That's probably why, or other external libraries. It's probably better to do the, because in general I also think like that, the less libraries you can use, the best. Because there's less points of failures, I think. I was going to study something and I forgot already. Next time it's probably better to write it down. I remember seeing something here that I said that I was going to study before, but I forgot. What is it? I was trying to remember so I can write it down. I guess was the UQ 112 overflow thing. But I'm not sure. Maybe it was something else. So this is the function for the liquidity, probably. We provide the lower and upper ticks. I guess that's where it stores the position. Is this one and the other one that I want to look at? This one and this one. And doesn't look like it found anything. Yeah. So it's just a struct. It's definitely here somewhere, this one. Yeah. Callbacks. Not sure if I understand what's going on here. I guess it's using the function from the interface, but I don't understand how this works. I guess it stores the data on this contract using the function from the interface. That's probably what's happening. And that's the other function there, I think. And the modify position params is the struct that I just looked at. Yeah, but it doesn't look like there's anything that says that it's talking about time, so I guess you can mint and burn anytime you want. As long as obviously you have the balance to burn. And then you can provide the ticks as well. I guess that's where all the math comes. This should be really interesting to look at because it's related to the math about the difference in reserves when you swap, I think. It's probably gonna have some logic to do with that. Which is the most difficult part to understand, I think. These and the tick files that I have to look more into, because those are the parts that I think the ticks are probably the ones that are related to the virtual reserves, because that's what determines the virtual reserves. But I thought there would be something more explicit when it comes to the formula on these contracts, the formulas that they have on the white paper. Maybe they are, and they just didn't look into it yet. And I guess this is related to the math about what happens when you swap the tokens. There's probably gonna have something related to that, but and there's a lot of stuff here. The tick bitmap is probably the one that has the logic there. This is really complicated. It's probably because I'm already tired already. Studying so long. Just giving a brief look before I stop streaming, because obviously I'm gonna look into this more some other time. Just trying to get familiar first, so I have an idea of what's going on, and then some other time I'm gonna dive deeper, I think, and try to really understand how everything is working there. Obviously, it takes time because there's a lot of different files connecting to each other. There's so much other stuff that I have to study as well. Yeah, okay. I think I'm gonna stop here. I ended up not really looking into this that much. I think this is good, but I'm already really tired, so I think it's not gonna be worth it to keep going now. And maybe next time it's probably better as well to, hey man, Blaze. I wasn't looking at the chat, so yeah, if you're still there. Uh, what I was saying. Yeah, it's probably better. I think because I'm more curious about the smart contracts themselves and not the UI so much. I'm also interested, very interested in the UI and the data analysis stuff. Not data analysis, the analytics that they use with Google to get the data from users. That's also really interesting, and I want to look at into that more in depth as well. But I think the priority for now is to understand how the contracts work, and I want to understand especially the liquidity, the virtual reserves thing, and the swap as well. Because I remember studying the papers talking about the swaps, and the formulas are really complicated. They're not actually complicated, but if you're gonna compute them, then it becomes really difficult for me because yeah, it involves a bunch of different things. So I think it's better to look at the smart contracts first, get an idea, and then if I have time, some other time looking into the UI. But I'm not sure how far I'm gonna go with studying the Uniswap stuff because I'm also thinking about studying the Cardano, Solana, and other ecosystems, so I have a better understanding and vision of how these different protocols work. Because so far I've only been studying Ethereum, and I got kind of in depth in Ethereum. And I think now is a good time to get familiar with the other ones, so I have more options and possibilities. And I'm also maybe in the future when I get the hardware, then I'm able to get more data from all these different protocols and yeah, and continue to pursue the vision that I have. So that's the plan at least. It's probably gonna change a lot, but next time I'm probably gonna go back to studying this again. And if not, then I'll probably continue to study the rollups or maybe study Cardano and Solana. I think Cardano and Solana are the main ones. And then, yeah, those are the main ones that I want to study outside of this, at least first, at first. And also, maybe I'll look into the optimism and these other contracts to understand how the bridges work from their rollup stuff, which is really interesting. And I also think there are going to be a lot of applications when it comes to that, to rollups and zero knowledge proofs. So I studied that a lot more as well. So I'll probably be back maybe 2 days from now or some other time. So see you then.